Okay. So our final year project is AI chatbot based test text analysis, and our teammates are Shalini, Srinidhi, and Sasti. And our guide is Mr. Santosh Kumar sir, Assistant Professor of CSE Department. So what our project is going to do, it will classify the disease like pneumonia or tuberculosis or normal. So it will allows the DICOM images and non-DICOM images also, so that they can process, the doctors also can process with the metadata. So how data processing happen is the efficient net B3. We are using the algorithm efficient net B3 that accepts the pictures of pixels 300 into 300, that will convert the grayscale images like monochrome images like black and white to the RGB colors, so that it can processable with a particular algorithm. So model architecture is of different layers and all. I will going to explain the code. TensorFlow is the library we can use because it consists of the ResNet and EfficientNet, all the models. Instead of PyTorch, it contains the different models, but it contains TensorFlow contains the pre-trained models that we need, and EfficientNet the algorithm, and OpenCV Python headless, that is the thing that process the images without showing in the window. That why we use the headless, and PyDicom that will process the images, and Matplotlib, as we know, that plots the graph, and pandas that handle the data set, and image augmentation that will help us to augment the images, and animations, that is the modern thing that will going to augment the images in a modern way. And the TQDM is a library that is going to show the process bus, how many epochs you are completed, how many steps you are completed, and all. And we are going to upload the drive, that is the content of the data set, and we are labeling the models, that is normal is equal to 0 and pneumonia is equal to 1 and TB is equal to 2, so that we can classify the models. And here it goes to the each folder, and it goes to the each file name and add the label. If it is a normal thing, it will add the 0. If it is TB and 1, like that, it will go to the every folder, or every folder in every file, so that it will assign the model. So total images found, that is 6641, and if GP is available, it will be listed, and it will help us to process in efficient way. And these are the libraries OS for the folder handling, and NP is numerical structure and numerical operations. Pandas, as we know, these are the things already discussed. Seaborn is a heat map that will show the intensity of the colors, through the intensity of colors the output. So, and here comes the Keras application, where Keras is a high level API, so that it contains the layer architecture, and we can, and contains the pre-trained models and all. And we are going to import the model efficient B3net, and dense layer global average pooling and dropout and batch normalization. These are the layers where dense layer connect the each layer to the output layer, and global average that will average the model, so that features maps, that is if the pixel of image is 10 into 10 into 512, it will averages into the single vector, so everyone can use global average, so everything can use by this method. And dropout, that is some layers must be dropout in the process of training, so that uh, images or features not memorized every data set, only it will generalize normally instead of memorizing the full data set, so it will give the particular output. And batch normalization is when you are going to give the input for from a output layer of a previous layer, so it will normalize it so that it can process easily. It may be mean is equal to 0 and standard deviation is equal to 1. And we are going to import the model such that there are two types of model: sequential model and functional model. This functional model contains input and layers and output, where sequential model contains only layers. And Adam is an optimizer such that adaptive training, such that it's going to update the weights, how much weights should be updated. And model checkpoint, that will be if the accuracy is high, validation loss is low, the model checkpoint will save the that model. And early stopping, if the epochs are not increasing, if the value loss is not improving, ಅಂದ್ರೆ decreasing ಆಗ್ತಾ ಇಲ್ಲ ಅಂದ್ರೆ early stop, we use the early stopping, so that the best model path can be saved. And reduce LR, so we are going to reduce the learning rate, so that the model can learn easily if the validation loss is not improving. So PyDICOM CV2, that is CV2 image processing images, and PyDICOM pixel from applied at wide violet. So it will process the images of the DICOM images in the basis of contrast or colorness. And scalar model selection, we are going to train test split, that is 70% training, 15% and 50% test and validation. Stratified shuffle split, what it is going to do, if the uh, it will select the 70% of the images from every class, that is from TB and pneumonia, and TB, pneumonia and normal, and with the 50% of DICOM images and 50% of the non-DICOM images. And classification report, that is going to F1 score, accuracy and precision, recall, that all comes under classification report. Confusion matrix, how much actually predicted in the uh, how much predicted in the actually cases. And accuracy score, how much accurate is our model. And compute class weight, that is um, we are going to increase the weight for the minority of classes. In this case, we have 700 images of TB, so that we must increase the weight. And this is for plotting the graphs. And GC is a garbage collection, so that we can erase the memory if they are not important. And glob, that it is a library that will collect the file paths, or analyze the file path with a particular patterns. If it is DCM, it will collect the DCM paths. So like that. Import random, so we use the random seed 42 for the randomness shuffling. It is here. And project configuration, image size, that is 300. Batch size, that is how much images processed per step or per thing, that is 32 images per step. And epochs are 30, just for our convenience we write here. After that we will change. And learning rate, that is how much weight should be updated during the training, that is E is equal to 10 to the power minus 4. And fine tune layer, only LR learning rate, how much should be there, that will decide by this. And labels are this one. And class names, we go to the class names and will return the length of the labels. These are the data set parts. And we, as I have said already, how the splitting done, that will be here. And this thing is going to collect the file paths such that, that is labels and formats and file paths labels, that is 0 1 2. And formats, that if it is a DCM and non DCM, it will takes the path like DCM and uppercase DCM and all. And each class that is going to each label, and it will assign the data set path with a class name, that is TB or whatever that thing. It will assign it. If the extension is DICOM, that will be extended, and it will going to create a file path that is uh, previously empty, and it is going to update that DICOM and non-DICOM paths. And for each DICOM and non-DICOM paths, it will assign the class name like TB, as we have, as we can see here. Class label, that is 0 1 and 2. And DICOM files, if it is a DICOM file, that is going to update the file path with a 0 if it is normal, or 1 if it is look like this. And format dot extend, that will be length of the file. And DICOM, if it is a DICOM or non-DICOM, that will be updated here. So that will be used for the image processing. If it is DICOM, how it will process. If it is non-DICOM, how it will process. So
We will be discussing about requirements and edge cases. First, our model isn't just a simple yes or no classifier. It's a multi-class classification problem. Like if we have used a normal or only pneumonia detection, then it is a binary two-class classification problem. Since we have used three-class classification like normal, pneumonia, and TB, it is a multi-class classification problem. It has to figure out if an X-ray belongs to one of these three categories. Now, Since in our data set there is a low fewer TB cases or urea cases. There are few TB cases. So if we just train like that, the model might ignore the TB cases. To fix this, we balance the data set. We will do oversampling. Uh, in oversampling, the TB cases more often it repeats the TB cases, and also the data augmentation. Like in data augmentation, it rotation, flips, brightness changes. So the model sees more variety in TB X-rays. So this helps not to miss the TB cases in the model. So and in the input format, hospitals store more DICOM format images, so which is different from normal images files like JPG, PNG, or something. DICOMs sometimes come with brightness or contrast issues or inverted colors. So we handle using VOILUT. It means value of interest lookup table. We have three branches: training, testing, validation. For training, we have provided 70% of the data for training purpose, and 15% for validation, and rest 15% for testing. Finally, we put special focus on TB, since the TB data set is very few. So we track TB's precision, recall, and F1 score separately.
In demonstration and correction, learning training logs show training log shows the epoch wise accurate whether it is accurate and or not, and loss tendency conforming learning process we can find in the training logs, and confusion matrix heat maps visualize classification performance across classes, and the classification reports provide detailed prescriptions about the patient details and whether it is there or not, and recall and F1 example prediction and example prediction where Gradio chatbox demonstrate the real-time influence on the chest X-ray analysis. And TB detection summary highlights improved the sensitivity to class and balancing and argumentations. Here we can find the accurate details of in the training logs. And the next will be continued by Srinidhi.
I'm Srinidhi. I'm going to explain about key highlights of our AI pipeline. Robust handling of DICOM, which means digital imaging and communication in a medicine, finds the standard format used in hospitals. And a standard images ensures the word applicability, which supports standard images formats, PNG format, which can upload from mobile devices or scans, atomic automatic normalization of image dimensions, and a construct of consistent analysis. Next one is efficient TF data. TF means TensorFlow data. Pipeline accelerates training and interface to handle a large scale medicine imaging datasets. An optimized input pipeline in crucials. TensorFlow data API enables fast, memory efficient, and scalable data loading, which preloads the next batch while the current batch is being processed. Handling large datasets, example images, text, and medical scans. Next one is a two-phase training strategy leverages transform learning effectively. Transform learning ensures that model benefits from a pre-trained knowledge like ImageNet or a large test area dataset, while adapting to a specific target dataset. Starts with a pre-trained model. Examples: ResNet trained on a large dataset like ImageNet. Next one is a focused evaluation and augmentation, improve TB detection and addressing crucial minority classes challenge. TB detection in chest area analysis is a minority classes problems Positive TB cases are a far favor than a normal cases. For the focus evaluation makes sure the performance metrics reflect the TB detection quality, not just overall accuracy. And augmentation for lack of TB positive cases strengthen the model and ability to generalize. Which next one is user friendly deployment enables partial clinical use and accessibility. Simple interface means web apps, mobile apps. Through this, we can upload images and it will detect the diseases. Minimal clicks like upload X-ray and it will we will get the results. Visual explanations means trust and transparency. Thank you.